I want you to look at the functions that we have on the screen. It says rational functions of the form f of x equals ax plus b over cx plus d. So linear on top, linear on the bottom. What is the first difference that you notice which might make a significant change to one of the things that we've been talking about so far? So for the first time, the asymptote is not going to be at the x-axis, not at the y equals 0 line. And I'll tell you where it is in just a minute. But that's the first observation that is very, very relevant. For the first time, the denominator and numerator have the same degree. Before it was that the top was lower than the bottom, and then in that case was where the x-axis was the asymptote. So I'm going to go ahead and ask the smartboard to draw this. Well, before I draw this in, can you tell me where the vertical asymptote is? Because we know enough now for us to tell where the vertical asymptote is. Do we know where the VA is? Can anybody help me out with that? Where's the VA of this function? X equals 2. Well done. All right, absolutely agree with that. So I'm going to go ahead and put that VA in, and then we're going to talk about where the HA is. So here comes my VA. Let me change the color of that, make it, I don't know, red. And I always ask you to put these things as dotted lines. So that's what I'm going to do right now. X equals 2 is somewhere around here. So there's my VA right there, x equals 2. And Jeremiah, always remember, it's always an equation. So not just 2, but x equals 2. Okay. Well, what I'm going to do now is I'm going to let the smartboard put the graph in and then ask you what it looks like that horizontal asymptote is. It is a horizontal asymptote. So here comes the graph. We have the vertical asymptote. Oh, look at that. Our vertical asymptote is spot on. But does anybody, by looking at what I can make this a little bigger for you. Right, I'm going to zoom in some more to maybe 200. Where does it look like that horizontal asymptote is now? All right. Okay, Jeremiah, go ahead. What do you think it is? What do other people think? Is Jeremiah right? Agreed. Okay, Aksa and Harish are jumping on and Caris is dead. You're all jumping on the Jeremiah train on that one. And you're all right. Y is equal to 1 is correct. So where did that come from? How does the equation lead us to this asymptote? All right, that's the question we need to ask. But before I answer that question, let me go to a second graph. So we all agreed on that. The x equals 1. In fact, let me put that asymptote in. All right, so let's drop that in. Another dotted line will make it red again. All right, so we're going to put another asymptote in right about here. Perfectly fits the graph. Okay, let's go to a second equation. How about this one? 3x minus 1 over 2 minus x. Let's define the the VA first. What is the VA of this graph? Before we go any further, can we define a VA for the graph? We're going to get to the HA afterwards. What's the VA for this graph? Okay, so we're hearing Janaya say x equals 2. Travis, you got to remember, it's an equation, like I was just saying to Jeremiah a few minutes ago. You got to say x equals y equals or some other equation of a line. So in this case, it's the x equals 2 line. Okay, so I'm going to put that in a second. Let me draw my line in first, right? And then we're going to see if we can sort of put that graph in and see if maybe there's some connection between the equation and the graph. So we have our VA, right, x equals 2 line, makes sense. And I'm about to put in now the graph and ask you if you can see, and Kriyu Janaya, good, Jeremiah, and I'm going to see if anybody can see what's happening with this horizontal asymptote. So here comes the graph. Okay, there's my graph. What would you guess is the horizontal asymptote in now as you can look at it? So you're saying y equals minus 3. Okay, that comes from Emily, that comes from Jeremiah, that comes from Travis. Actually, no, Travis is He says y. Okay, I think he meant y equal. Yeah, right. Okay, good. So I'm going to agree with all of you. Right? So we knew the VA was at x equals 2. But now we find out that the HA is at the y equals minus 3. Is there something about this equation that is giving us that HA? Is there a way that we could have figured this out? By the way, let me put that HA in first, and then I'll take your answer in a minute, Jeremiah. Let me put that HA in first, right? Let's agree with all of you who said that it was at the y equals minus 3 line. Let's put that in and show that it does fit nicely. Yeah, seems like it does fit very nicely. And Jeremiah has a theory about this. Jeremiah, what's your theory about this? Let me show you the equation again. Go ahead, Jeremiah. Mm-hmm. 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 Yeah. Mm-hmm. Mm-hmm. So you're saying, let me see if I understand you right now. Take the ratio, because how when you divide something, you get a ratio. Take the ratio of the leading coefficients. Is that what you're saying? So the lead coefficient of the top divided by the lead coefficient of the bottom, which in this case would give us minus 3. And if we did the same rule for the first graph, we'd have 1x over 1x, so that would be y equals 1. So guess what, Jeremiah? You just hit the nail on the head. The HA, oh, that's not what I wanted to do. Let's get rid of that. Let's get rid of that. The HA, this is when the degrees are equal. So the degree of the numerator and denominator are the same. Right? That is going to be equal to the ratio of the lead coefficients. And I'll use LC because we've used that as a short form before for lead coefficient. Can I re-explain? I sure can, Janaya. So let's look back at the top of this function, the numerator, and ask you, if I multiplied this out, I would get 3x minus 3. Would you agree with that, Janaya? If I multiplied out the top? Okay, so let's write that down. So 3x minus 3. And on the bottom, we have 2. Let's put minus x first, plus 2. You'd agree that I could put minus x plus 2 instead of 2 minus x. That's the same thing, isn't it, Janaya? Okay. Now, what is the... This looks like it's a minus here. I'm going to just erase that so it doesn't look like it's a minus. Put the equal sign all the way over here. And this is a minus here. So let me ask you this then. The coefficient of the top is 3. The coefficient of the bottom is lead coefficient, I should say, lead coefficient. The lead coefficient at the bottom is minus 1. Would you agree with me on those two numbers, Janaya? Okay, let's divide those two numbers. So divide 3 by minus 1. What do you get when you do that? Correct. And that's what the HA is. Whatever the ratio of those two numbers is, when I divide the coefficient of the top by the coefficient of the bottom, if it's the lead coefficient, I get what the HA is. That's exactly right. Does that make sense? Okay, great. Thanks. And thanks for the question. Now, we have enough information to also get the x-intercept. I want you to go back and look at the function again, right? And tell me what I can fill in here. I know we have the graph. I can see we have the graph. But if I did not have the graph, would I have enough information from here to figure out the x-intercept? Can anybody tell me what the x-intercept of this graph is? Not looking at the graph, but just from what we know about getting x-intercepts. What would that be in this case? And I remind you, you get the x-intercept by setting your y to 0. Sorry, I saw some hands going up. Janaya has her hand. Let's just see who was first here. Hang on 1 second. Janaya was first, and then Jeremiah. So Janaya, what do you say is the x-intercept in this case? I know you can look at it on the graph and see it. Yes. Set the numerator equal to 0. Actually, you know what? You're not wrong. I'll tell you why you're not wrong. Right? You're not wrong at all. I'm going to create a brand new page here. Right? So on this page, I'm going to put what we had before: 3x minus 1 over 2 minus x. Now, to get an x-intercept, we set that equal to 0. Right? Because that's what it says. Y equals this thing. Now, if you were to cross multiply, this is how you solve a rational function. You cross multiply. If I cross multiply, then it means I'm taking this side and multiplying it by this side. So I'm going to end up with just simply the top, which is 3x minus 1 equal to 0. So really, when we have a rational function and we're trying to find the x-intercept, we should just focus on the numerator. Whatever makes the numerator equal to 0 would be the x-intercept. And what makes this numerator equal to 0? Well, you can divide both sides by 3 if you like, right? And you're still going to have 0 on the other side. So x minus 1 equals 0. So therefore, x is equal to 1 is what Janaya just said is the x-intercept. So always, when you're trying to find that x-intercept, and this also works for when we're doing this before with the other functions, x-intercepts come from the numerator. You don't have to do a lot of work to get the x-intercept, just focus on the numerator. Don't look at the denominator because that's not where the x-intercepts are coming from. So, Jeremiah, that was what you were going to tell us because you had your hand up as well. Was it something similar? Jeremiah, please go ahead. Mm-hmm. Yeah, you'd get 0, right? And so really just focus on the numerator. Set the numerator equal to 0. There's your x-intercept. Okay, and you can see very clearly from my graph that it does cross. Okay, I didn't circle it very well. Let me try that again. That it does cross the x-axis at 1. How about the y-intercept? What is the y-intercept? Again, you can look at the equation and tell, right? What is that y-intercept? Anybody? Y-intercept. And I know we can look at the graph as well, but I want you to do this algebraically. If I didn't have a graph, if I didn't have a fancy smartboard graphing tool or Desmos or something else, and I was just given the equation and asked for the y-intercept, how would I do it? 3 over 2, Travis says. And Travis, and Noah says -3. Okay, I think you both said negative. Yeah, you both said negative. And you're right, right? And you understand that to do that, you just simply plug in 0 for your x, right? That's going to make both of these things go. This is going to go and that's going to go left with -3 over 2. So -3 over 2 represents my y-intercept. And that should be pretty clear from the diagram as well. You can see that on the diagram, just above the -2 and just below the -1. Somewhere in there, kind of -1.5 is my y-intercept. Okay, now let's answer some more questions. Let me erase this, give you a little bit more space to look at what's going on. Where is this function greater than 0? All right? Where is this function greater than 0? Now remember, greater than 0 just simply means the following. Jeremiah, looks like is your hand still up from the last time, or you have an answer for us now? Okay. Greater than 0 means just look at the graph and ask where is it above the x-axis. That's all it is. That's all it is. Right? So don't give an answer like 6 or 7 or 9 or 52 because greater than 0 is probably going to be an interval. So it's going to be from this point to that point. Okay, so Emily says from 1 to infinity. That's where it is. I'm not sure. I'm going to have to say no to that one, right? Look at Harish's answer, though. Look at Harish's answer. Let me tell you why Harish is right. And I know why you said 1 to infinity, by the way. I think you're thinking about where it's going and it is moving towards infinity. But the only place, and I'm pointing to it right now, where this is above the x-axis is when you get to 1, not including 1, because greater than 0 means that you are not including where it's crossing the x-axis. So starting at 1 and going all the way up to 2, but not including 2, because 2 doesn't even exist on the function. Okay, let's get to end behavior now. Now, I won't have enough room up here to do end behavior, so I'm going to take it down to down here, right? So EB, end behavior. Remember that end behavior, when we were doing just regular polynomials, we could have just talked about Q this and Q that. We can't do that anymore. So we're going to have to ask, as x tends towards minus infinity, where is y going? And as x tends towards positive infinity, where is y going? That's what we're going to be asking now. So let's go back and look at the graph again. So as I move, and watch the mouse, as I move further and further and further towards minus infinity, as I go this way, what y value does it seem like I'm approaching? Is the question I'm asking. What y value does it look like the graph is getting closer and closer to? So as I move towards minus infinity, as I go further this way, right, further and further to the left. So Harish is saying -3. Travis is agreeing. Is everybody going to agree with that? -3, does that sound right to everybody? Does it look like the graph is approaching -3? Yes, and that's exactly right. So it looks like that horizontal asymptote seems to define what happens to the function as you get bigger and bigger and bigger. So if I went back to my calculator, and you can do this on your own, I started putting in bigger and bigger numbers for x, you will notice that the graph minus infinity, that is. And let me just cut to the chase here. If you go on the other side of this and ask what y value does it approach as you go to positive infinity, it's the same thing. It is also -3, right? It's the same end behavior on both sides. Whether you go negative infinity or plus infinity, both sides are tending towards whatever the horizontal asymptote is. I'm going to say C below. C below. Okay. Okay, now here comes the one that sometimes people have some trouble with, but let's see if we can do a good job of it this time. Where is the function increasing? Note, I did not ask where the slope is increasing. I'm asking where the function is increasing. And to answer that question, you don't need your hand rotating or anything. All you have to ask is, where is the function going up? That's it. Where's the function going up? Right? Because if it's going up, it's increasing. If it's going down, it's decreasing. And remember, you always go from left to right. Always go from left to right. So, can anybody tell me where the function is increasing? Where is the function increasing? I'll let you see the picture of the function again. All right, so there's your function right there, as drawn by the smartboard. Where is that function increasing? So Jeremiah says all real numbers as long as x is not equal to 2. And you're right. So it's increasing everywhere. It's increasing. So it's, and just follow my mouse as I move along. As I move from left to right, it's going up. As I move from left to right, it's going up. So it's increasing everywhere as long as x is not equal to 2. And that's because at 2, the function does not exist. So it's not increasing at 2 because there's nothing there. The function is what's called discontinuous at that point. Okay, now here comes the other question that I know people get tripped up on sometimes. I don't expect you to get tripped up on it though, because it's a good class. Slope is increasing, right? So where is the, I'll say it now, where is that rotation going counterclockwise, right? That's what we're asking now, because a counterclockwise rotation means that my slope is increasing. A clockwise rotation means that my slope is decreasing. So where on this picture is my slope increase? I want to put a line on here, right, Janaya? I'm going to put a line on here, which is a tangent line. I'm going to put my first line maybe about here. Now, remember what a tangent line is. A tangent line means it's just touching the edge of the function, correct? All right, Janaya? Okay, so I'm going to put one somewhere around here. Actually, I want a solid line. I need a solid line. Let me take that away. I'm going to put a solid blue line. So here comes my first line. So that's a tangent line right there, right, Janaya? Yes? I'm going to put another one somewhere around here, touching the edge of the function again. Right? Would you agree that those are both tangent lines as I move from left to right? Okay. Now, comparing the first one, and I'll just select it, comparing this tangent line to this tangent line, there have been some turning that has gone on, right? It's been turned a little bit to move from one to the other. What direction would you describe that turn to be? Clockwise or counterclockwise? Absolutely. So as I move from left to right, as I move this line along the edge of the function, in fact, if I move it even further along, I think I can rotate it here. Let me see if I can do this. Yeah, there we go. All right. As I move it further along, it's rotating even more in a counterclockwise direction. So that would tell me what? Is it increasing or decreasing as I go from left to right on this section of the function? Can anybody answer that? Go ahead. No, go ahead. Absolutely. So it's increasing between minus infinity up to 2. So from minus infinity up to 2. Can I union that with anywhere else? Let me remove these lines now. Let me get rid of this line. Let me get rid of this line here. Is there anywhere else where that is happening? Not just Janai, but everybody else. Should I union that with another part of the graph, or is that it, where the slope is increasing? Jeremiah says no, nothing else. What do other people think? Janai, what do you say? Go ahead. Well, let's start with the first one. Go. Mm-hmm. Okay, so it's not a second function, it's the same function. Just remember that both of these are part of the same function. This function generated both parts of this. Even though it's discontinued, even though there's a discontinuity in the function, it's not like they're two different functions, it's the same function. That's one. Two, I think your second question was, do we just ignore the part down here? Well, is it increasing over here? Let's put some lines on here as well. So let me start off with a line that is maybe just about right here. Let's say this is the first tangent right there. Let's draw another tangent somewhere around here. If you compare those two tangents, this one here and this one here, this one first, then this one second, is the rotation clockwise or counterclockwise? What would you say to that, Janaya? Absolutely. And that would mean the slope is decreasing. So to answer the question, which people are asking, and including yourself, it would mean that this second part down here, second part of the same function, the slope is actually decreasing. So we're done with the part of the function which is increasing, and that's only this part over here, the left-hand side over here. That's the part that's increasing. So Jeremiah's answer to that is absolutely correct. Okay? Let's answer one more thing before we move along. Let's answer the behavior near the asymptote. So let's see what happens as x approaches the vertical asymptote, that is. The vertical asymptote here is at 2. So as x approaches 2, negative. And 2 negative doesn't mean negative 2. It means 2 from the left. All right, so what's y doing? And I'll do the same thing on the other side. As x approaches 2 from the right, what's my y doing? So let me go back and let's have a look at the graph. And let's see if somebody can answer that question. So as I approach 2 from the left, where's the function going? What would you say is the behavior near that asymptote? As I approach 2 from the left, come on, folks, you can do this. Where's the function heading as I approach 2 from the left? So let me trace it out. So I'm going towards, here's my vertical asymptote right here. I'm moving closer and closer and closer and closer and closer to that vertical asymptote. Where's the function going? No answers to that yet? Oh, come on, folks. I know you know this. So Noah is saying infinity, and that's a plus infinity, and he's actually right. Absolutely correct. So y is approaching positive infinity. I'm not going to put plus, but yeah, the plus is implied. And how about as I approach it from the left? Sorry, from the right. So as I come this way, as I get closer and closer to the function this way, where is the function heading? As I get, sorry, not to the function, to the asymptote, to the vertical asymptote. So Emily is right. It's going towards minus, and Jeremy is right. It's going towards minus infinity. So let's just put that in. Okay. Okay, so far so good. Let me save that and move along. Okay, now let's see if we can fill in this table as far as we can before we actually draw the graph, right? Let's talk about the VA. Okay, I don't mind you calling Jeremy. It's my nickname. I see. Okay, Jeremy. Okay, we can do that. All right, so let's talk about VA in this case now, right? Where's my VA on this one? Okay, so Noah says x equals 0. Harish is agreeing. What do other people think? It's time for my call out. You know, I like to do my little call out as I go along here. Joel, what do you say? Are you on board with what we're doing? Are you following along here, Joel? Where are you, Joel? You're there. Okay, good. And does that answer that Noah just gave make sense to you, by the way, Joel? You think it's x equals 0 too? What do you think? You think it is? Okay. I'm not giving a verdict on that yet. How about Nicholas? Nicholas, are you with us out there? Where's Nicholas? Nicholas, where are you? Okay, yeah. So are you following along so far? Does this all make sense? It does. Okay. So I'm going to agree with what Noah said a few minutes ago. X equals 0, same as the y-axis, is my vertical asymptote. Where's my HA on this one? Right? We just learned, Jeremy came up with a sort of a general rule about this, that we can figure out the horizontal asymptote where the degrees are the same. And the degrees are the same here. It's a linear over a linear. So where is the horizontal asymptote on this one? Where's the HA on this one? What do you say to that, folks? And remember, give me an equation. Don't give me a number. Give me an equation. Where's the horizontal asymptote on this one? Anybody out there? Hello? Is there anybody out there? What is the equation of, oh, you know what? I just realized that. Sorry, folks. I just realized that I was way up in the chat and I didn't realize that I had a whole bunch of answers there. So y equals 3 is the horizontal asymptote. Yes, thank you very much, folks. Thank you very much. Good. The x-intercept. Now, we talked about this a few minutes ago. So I should be able to get a whole bunch of answers to this, right? I'm not going to draw this yet until you tell me where this x-intercept is. I think it was Janaya who noticed something about x-intercepts, and I talked about it the last time. So where is the x-intercept on this one, right? Looking, and Harish is saying x equals -2. Really? Is that what everybody thinks? What do other people think? All right, let me check in with the room again. How about Riddy? Riddy, are you there with us? Where's Riddy? Okay, does that make sense? You agree with what Harish said? Or you have a different answer? Joel is, okay, all right, okay, fair enough. So x equals 2, yeah, -2, I agree. How about the y-intercept? What is the y-intercept on this one? And remember how to get the y-intercept now, right? So Joel thinks it's 0, Rachel thinks it's 0, Jeremiah, oh, Harish has a different answer. Okay, so we got a couple of zeros and got a couple of nones. That's interesting. So which one is it? 0, wait, none, it's not. Okay, so we're all over the place on this one. Jeremy, what do you want to tell us? So it's undefined when you plug in x as 0. So it is in fact none. And there's a good reason for that, right? The vertical asymptote is the x-axis. So if there's a vertical asymptote there, then it's not going to have a y-intercept because the y-axis is the x equals 0 line. They're one and the same, right? Don't forget that. X equals 0 line is the y-axis. So let me put those asymptotes in, the ones that you just mentioned. right? So let's put in that line first. Again, all asymptotes are dotted lines. I want to remind you of that. Anytime you have to draw me a graph, make sure it's a dotted line if it's an asymptote. So one of the asymptotes is right on the y-axis, right there. And then the vertical asymptote, that's a vertical. And the horizontal asymptote is the y equals 3 line. So that's somewhere around here. Okay. And what else do we know? We know the x-intercept is at -2. So we put that in. X-intercept is at -2. Here's what this tells me. If I had to sketch this graph right now, I have a pretty good idea of where the graph is. I'll tell you why. Whenever you're drawing, and this is a little rule of thumb that I want you to always remember. Whenever you're drawing any of these functions that are linear over linear, it is going to look a lot like those reciprocal of a linear function. And I remind you what those look like. Reciprocal linear function looks something like this. Maybe like that, like that. There's on opposites that like diagonally across from each other. It's going to be the same kind of thing here. So if I have one piece that is supposedly going to go through this -2, I'm going to suggest to you that this graph probably looks something like this. And I meant to go through the -2, so sorry about that. And another piece, that's horrible. Let me clean that up. That's not good. And this one doesn't go through what I wanted to go through. So let me try this again. Folks, I'm no artist. Like I'm warning you. I've been telling this all along. I'm not good at that. Let me try again. Okay, kind of got a little squiggly back. Come on, Mr. Kamak. Okay, that's a little better. And maybe a little better up top there. Okay. All right. Axa is laughing at me, falling on the floor, slapping her knees and saying, "It's like I just can't draw anything." Yes, Jeremy, go ahead. Mm-hmm. Well, it's a lot like, and thanks for the question, by the way. It's a lot like I was saying, the reciprocal of a linear function, where it's discontinuous, right? As long as you sort of accept that as is, and it's not like, and I know you said it's in quadrant 3 and quadrant 1, and I know you recognize that it's not all quadrant 3. There's a part that's in quadrant 2 as well. So it just depends on the graph. So I would say to you that as long as you accept that these functions are going to be discontinuous because they're rational, and rational functions always have a discontinuity in them, then if you put in those lines of discontinuity, right? Put in the horizontal asymptote, put in the vertical asymptote, they're always going to be diagonally across from each other. So it would have either have been like the way I have it now, or the other option would have been if it was like this here and here. But the reason that it's not those two is because those two don't match with the y-intercept that we talked about. Sorry, not the y-intercept, sorry, the x-intercept that we talked about. If the x-intercept had been a +3 or 4 or something like that, then I'd have opted for those. But because it doesn't have those, it doesn't connect to the y, sorry, with the x-axis at that point, that's why I didn't put that on. Janai, you had a question, sorry. Janai, you had your hand up. Mm-hmm. Mm-hmm. The vertical asymptote? Okay. So the vertical asymptote comes from the denominator. Always, let me take you back to the previous page for a minute. And we don't mind doing this, by the way. So nobody needs to apologize for asking questions. I encourage that, and I actually admire people who do ask the questions. So if you look back at this function here for a minute, Janai, and everybody else, look at that denominator. Set that denominator equal to 0. Whatever makes this denominator equal to 0, that's your vertical asymptote. So 2 minus x equals 0 will give us that x is equal to 2. Previous one, where it was x over x minus 2, x minus 2 equal to 0, that means that x is equal to 2 is the vertical asymptote. So in the case of the one we're doing now, x is on its own. So just set that equal to 0, and that becomes your vertical asymptote. Okay? Right. And then we talked about the y-intercept and x-intercept, and that's just plugging in 0 for x or plugging in 0 for y. Okay. All right. So I do have a version of it that we can show. This is our quick and dirty version of it, but I do have a smartboard thing here that I can use. So let's see now. Okay, let's first of all maybe send it to the front. Okay, so you can see it a little better. And I'm going to let the smartboard give you its version of it. Is it better than mine? Maybe a little. Well, actually a lot. Okay. It does still have the asymptotes where we said it would be at the y-axis right there. And the y equals 3 line is still the horizontal asymptote. All right. So nothing different there from what we did. Just a lot prettier than mine. Okay. All right. So let me disconnect this. And let's answer some more questions now. Let me take this away. Now, even using my not so great diagram, let's answer the question of where is the function greater than 0? Can you help me to answer that question, please? Okay, look at the picture. You see, having the picture, I keep telling you that a picture is worth 1,000 words. That was not, I didn't come up with that originally, but it's a truth that has come down through the ages. If I have a picture in front of me, it's a powerful way for me to understand what's going on. So where is this function greater than 0? And maybe I should tidy up this little part right here so that makes it more obvious, because right now it's a little bit blurry as to what's going on. We say it's crossing at -2, so let's just put that in. And I want to get back my black, so let's do this. Okay, not so bad. Sorry about that. My Wi-Fi keeps cutting out and kicks me out of the meet. Okay, Karis. All right, so let me come back to Jeremy's answer now. He thinks it's from -infinity to -2. Axel is saying from -2 to 3. And let's see now. Noah says from -infinity to -2, along with from 0 to infinity. I agree with Noah 100%. So there are two parts to it. There is, first of all, from -infinity up to -2. So let me put that in. -infinity up to -2, but union with anywhere after 0. So from 0 to infinity, right? It will continue being above the x-axis, above 0, once you get past infinity. The only place this function is negative is between -2 and 0. And by the way, none of these things have square brackets because none of the boundaries are included. So Jeremy is now on track with Noah, and you're both right. All right. So Axel, do you see why that answer is right? No, not from -2 to 3 as you were sort of thinking. Do you see why that answer is okay? Okay, great. End behavior. Now we should be able to answer end behavior fairly easily because we've done this before. So let's see if it is in fact that easy. So as x tends towards -infinity, where is y going? And as x tends towards positive infinity, where is the y going? And I talked about this a few minutes ago. So can anybody tell me what the end behavior of this function is? As x tends towards -infinity, where is this function heading? Where is it going? It's going towards 3 on both sides, correct? Because that is your HA. The HA really defines that. So I'll put C below here. Okay, good stuff, good stuff. Two more quick questions, and I think we have one more after this to do. Where is this function increasing is our next question. Noah says, and Jeremy says, nowhere and never. Well, is that true? It's not increasing, Kayla says. Jeremy says yes to that. Well, Jeremy says, okay, all right, yeah. Well, I'm going to agree. It's never increasing. Okay. Last question, because it's dropping as you go from left to right, dropping as you go from left to right. All right, let me see how really sharp you guys are now. I mean, I know you are, but let's just prove it. Where's the slope increasing? That's the question. Where is the slope increasing? I'm just going to let you see that graph there for a second and see what people come up with. Where is the slope? I'm not going to say anything except read the question. And you have to figure out how to get that answer for yourself. Where is the slope increasing? All right, so Harish and Noah have an idea, have a suggestion. They say from 0 to infinity. Noah and Harish. Anybody want to jump on that train? Or you have a different answer? Right? I like to hear different points of view. So Harish and Noah have the same point of view. Does anybody have a different point of view? Or are they right? 0 to infinity makes sense to everybody? All right, let's see. Let's see. Neil, are you there with us? Where's Neil? Where's Neil? Neil, calling Neil. Okay, you're there. All right. Does that answer make sense to you, Neil? Do you agree with that answer? Or are you not sure? Let me know if you agree or not. They say 0 to infinity for where the function is increasing. What's the question again? Wow. All right. All right. So Neil and everybody else, you got to stay with me here, right? I don't, it's not when I just call it that you're going to chime in. You got to stay with me. I'm asking for where the function is increasing. All right. That's the question we're on right now. Where is the function increasing? This last question right here. Sorry, not what function is increasing. I'm saying it wrong. Where's the slope increasing? That's what I'm asking. Sorry. Where's the slope increasing? So do you agree with those answers, or do you have a different answer, Andy? What do you think? Noah and Rudder, you agree. Okay, and I would agree as well. So from 0 to infinity is where the slope is increasing, because that's where the rotation is counterclockwise. Okay. Let's wrap this up with a little bit more challenging question. Let's see if we can get both of these in before the end of the class. Write an equation for a rational function that has a graph with all the indicated properties. Now we have to think back to what we know about the properties. Think back to how you get an x-intercept, because they say get x-intercept is 5. How do you get a y-intercept? They say the y-intercept is minus 5. Vertical asymptote is minus 8 over 3. How do you get all of these things? Horizontal asymptote is 1 over 3. Let's see if we can think this through and come up with a numerator and denominator which will make all of these features happen. And I always like to start with the denominator, right? What feature should I be looking at for the denominator? They give us the x-intercept, the y-intercept, the vertical asymptote, the horizontal asymptote. Which part of this should help me with the denominator? Right? Which of these? They gave us 4 pieces of information. Let me underline them. They gave us this, this, and this. Which of those should help us with the denominator? The asymptotes, you mean vertical or horizontal? I agree, but I need to know which one. The VA. Okay, great, great. So give me a VA that would have a vertical asymptote at minus 8 over 3. Give me one that would make that happen. I want a VA, I agree, of minus 8 over 3. What might that look like? What might that look like? So when I set, remember, vertical asymptote is when is something that makes the 3x plus 8. Let me write that down. So if I set that equal to 0, because that's how we get the vertical asymptote when Jenna asked me the question earlier on, that's what we said. If I set that equal to 0, would I get minus 8 over 3? And the answer to the question is yes, I would. Yes, I would. So that's a good place to start. That's a good place to start. What do you think I should focus on for the numerator now? Let's see if we can focus on the numerator now. Right? Which of those? So the vertical asymptote helps us out with the denominator. So let's just take that out for now. Which of those other things helps us out with the numerator now? The HA, maybe to some extent, but I'm thinking of something else that's a bit more specific that would help us out with the numerator. Maybe the x-intercept. I agree. We need an x-intercept now, and the x-intercept that they give us is 5. So give me a numerator that will give us an x-intercept of 5. So Jeremy says x minus 5. Let's write that down. X minus 5. Would that give us an x-intercept of 5? Can we agree on that? Chris says yes. Okay. Does everybody else agree with that? Reddy says yes. Right? Would that give us an x-intercept of 5? If I set that numerator equal to 0, would I get 5? Absolutely. Okay, so that takes this out. Let's check the other features now. Oh, sorry, that's the wrong one. That's the wrong one. That's the wrong one. So that takes out this one. Now let's check that y-intercept now. The y-intercept should be minus 5 over 8. Let's hope that what we have so far is going to work. Does that make sense for this question? Is the y-intercept of what we've written so far already going to give us minus 5 over 8? Yes or no? What do you say to that? All right, if I plug in 0 for x, do I get? I absolutely do. So this is working for us so far. How about the horizontal asymptote? Are we getting a horizontal asymptote of y equals 1 over 3? Is that working out for us as well? What do you think, folks? Look at the equation. All right, Harish is saying Janaya carries. Okay, look at that. And you're right, because the ratio of the lead coefficients would be 1 over 3. The numerator is 1, the denominator is 3, so therefore it would be 1 over 3. Y equals 1 over 3 is exactly what we have there. All right, so that makes sense as well. All right, so we don't have to do anything else to this. We hit it out of the park. Okay, the other one is a little bit more difficult, but we're equal to the challenge. Let's do it, and then we'll take a break after that. So here comes my second question. So it's the same two questions, but now we're focusing on the second one. So I'm going to cross out the first one. We've done that one. Now think back at the process that we went through the last time and tell me if you can come up with a starting point. What starting point can you come up with? They give us a vertical asymptote, x equals 3. They give us the horizontal asymptote of y equals minus 2. Then it says it passes through the point 2, 1. I don't know what we're going to do with that yet. But anyway, let's see if we can figure this out. All right. What can we do with the information we have now? Can we figure out either a numerator or a denominator? What do you think, folks? Is there enough information to help us out with either one of those? Anybody? Nobody? Denominator using the VA. Nice, nice. What VA do I put for that? Excuse me. X minus 3. Okay. I agree. I completely agree. Everybody see why that would give us a VA of x equals 3, right? That makes sense, correct? Are we good? Are we good? All right, let me check in with the room again. Rachel, how about you? Are you following along with us so far, Rachel? Where's Rachel? Okay, good, good. Hopefully that makes sense. And Sharisa, how about you? Are you following along so far, Sharisa? Where's Sharisa? That's good. And that makes sense? Okay, that makes sense to you, Sharisa, what we've done so far? X minus 3 is a good place to start. Sharisa, does that make sense? The denominator, what we wrote, what we put in? Or are you not so sure? You're good. Okay. No. The horizontal asymptote of x equal, we'll get to the passes through the point 2, 1 a little later on. The horizontal asymptote says it's y equals minus 2. How can we use that to build our equation or function? We know how we get horizontal asymptotes already. Can we use that information somehow? X plus 6 on top. I write that down and let's see if that makes any sense. X plus 6. Does that give us that horizontal asymptote of y equals minus 2? Remember how we get the horizontal asymptote? The ratio of the lead coefficients. Are we going to get that from this? Noah, what do you think? Okay, Harish has a different idea, but let's just see what Noah thinks. I was thinking about you're thinking about intercept. You're right. So that's not going to help us. So let's take that out for now. Let's take Harish's idea for a minute. He says it needs a minus 2x on the numerator. So if I put a minus 2x here, would that give us a horizontal asymptote of y equals minus 2? It does. Well, it could have another constant. So let's say that's a plus b then. We don't know yet what that might be, but minus 2x plus b is we already know that that will fill, let's tell you what that fulfills. That fulfills this vertical asymptote, and that fulfills this horizontal asymptote. So far, that works. The only other piece of information we have is that it passed through the point 2, 1. What are we supposed to do with that? How is that going to help us out? Any ideas as to what we do with that piece of information? It passes through the point to plug it in. Thank you, Noah. So this is my y equals so far. And if I have this pair of numbers for x and y, I can just throw that into the equation and see if I can figure out the b. So let's do that, and then we'll take our break. So y would be 1 is equal to minus 2 times the x value of 2 plus b divided by 2 minus 3. Right? Anywhere I saw x, I put in 2. Anywhere I saw y, I put in 1. Okay, let's keep going here. Let's see if we can solve this, and then we'll take our break. So 1 is equal to minus 4 plus b over 2 minus 3 is minus 1. How do we solve this exactly? Right? We're going to talk about solving rational equations in the next and inequalities, by the way, in the next class. But if I just gave this to you and said solve it, what would you do? I want to solve for b times both sides by the minus 1. So we're really cross multiplying. You're absolutely right. So I'm going to take the bottom of this side, multiply it by the top of this side. Actually, let me put that in a different color. So I'm going to take the bottom of this side, multiply it by the top of this side, and I'm going to get minus 1 times 1 is equal to minus 4 plus b. Okay, so minus 1 is equal to minus 4 plus b, and therefore b is equal to minus 1 plus 4, which of course is 3. So I think we have our equation. Our equation is y is equal to minus 2x plus 3 over x minus 3. So we know from the information we have that this does have the vertical asymptote right where we want it at x minus 3. This has a horizontal asymptote at y equals minus 2, ratio of the lead coefficients, minus 2 over 1. And it does pass through point 2, 1, which we can just double check by plugging 2 into this and see if we get that 1 back, right? We should, but again, it's not a bad idea for us to double check that. Plug in the 2, see if we get the 1, and if that's the case, we're good to go.